All right, we're going to practice the normal distribution curve stuff we've been doing in class. This is actually called the empirical rule. We've just been calling it the 68, 95, 99.7 rule, but I talked to the statistics teacher to help me out with some stuff, and I didn't realize till now it's called the empirical rule. All right, so let's say we have a question like this. So the grades on a test follow a normal distribution with a mean of 85 and a standard deviation of 4. What is the range around the mean that includes 95% of the grades? So to do this using a curve, again, this only works if it says that we have a normal distribution, or it might say if we have a bell curve. So there's our curve. In the middle, we know that our mean, which was given to us in the prompt, is 85. And then we're going to determine, and it tells us also that we have a standard deviation of 4. So we're going to label 3 standard deviations above the mean. So there's 1, 2, 3, and 3 standard deviations below the mean, -1, -2, and -3. So we know from what we've learned in class, but because of the empirical rule, that 68% of the data falls within 1 standard deviation of the mean above and 1 standard deviation of the mean below. So there's our 68%. We also know that because of the empirical rule, that 95% of the data falls within 2 deviations below the below the mean, and 2 deviations above the mean. And then just to review, even though it's not actually part of this question, we know that 3 standard deviations below and 3 standard deviations above equal 99.7% of the data. Now, you can break those up. Oh, I didn't put 99.7, but that's 99.7. You could break those up so that we would know that 34 and 34, for example, make up half on each side there. But the question is, what is the range around the mean that includes 95% of the grades? So 95% is going to be 2 deviations above and 2 deviations below. So we need to calculate those numbers. So 1 deviation above is going to be 85 plus 4, because 4 is our standard deviation. So we've got 89, and then we've also got another plus 4, and that would be 93. To look at below, we're going to subtract 4, so 85 minus 4, and we've got 81. And then we've got another 81 minus 4, and that's going to be 77. So our range for what is included in 95% of the grades is a 77 to 93. So 95% of the students who took this test scored between a 77 and a 93. I'm going to pause it and we'll do another one. All right, let's work through one more. So in this one, birth weights follow a bell-shaped curve, that's another way of saying normal distribution, with a mean of 3 kilograms and a standard deviation of 0.5 kilograms. What is the approximate percentage of birth weights between 2.5 kilograms and 3.5 kilograms? So we're going to draw our bell curve. It gives us our mean, which is 3 kilograms, so we can say 3 kilograms, and our standard deviation is 0.5. So we'll go ahead and label out our deviations here. So -1, -2, and -3, +1, +2, and +3. So since we're only adding 0.5, we've got 3.5, 4, and 4.5. And then below, we'll have 2.5, 2, and 1.5. So the question again is, what is the approximate percentage of birth weights between 2.5 and 3.5 kilograms? And this one's pretty easy because it's only asking us this area to this area, which is 1 deviation above and below the mean. So 2.5 to 3.5. And we already know that according to the empirical rule, that would be 68%. So 68% of birth weights are between 2.5 kilograms and 3.5 kilograms. Now, let's say if the question was actually 2.5 to 4. So then we could include what we already have, the 68%, but then we would need to figure out this additional area right here. Well, we know that this is going to be half of the 2 standard deviations, which would be 95%. So this here is, well, all together here, is 95%. So half of 95% is going to be this area. We won't have a calculator on our AP exam, so that's why we're going to do some basic math here. So we've got 47.5 makes up this whole area right here. And really that's a percentage that eventually you'll have memorized and you won't have to remember. So, and then we have 2.5 to 3 then, and 3 to 4. So 3 to 4 is 47.5, and then 3 to 2.5 we can tell is 34%. So we're going to add 47.5 and 34%. 7, 8, 9, 10, 11, 5. So that is 81.5% would fall in that range from 2.5 to 4. All right, that's it.